Hello students, welcome to MJC Learning. I am Manju Dilip. Today I am going to start with the 12th standard mathematics topic Differentiation Part 10. We already studied different types of differentiation in this chapter. So today's topic is derivative of parametric function, and we are going to solve some questions from this exercise also. The first question is find dy upon dx if x is equal to 80 square, y is equal to 280. So in parametric differentiation, we have already studied one theorem. The formula is dy upon dx is equal to, here the function is in terms of t. If it is in terms of t, dy upon dx is equal to dy upon dt upon dx upon dt. So in this type of differentiation, we will get both x and y in different functions in terms of the same variable. Here x is equal to 80 square, so t is the parameter here, and y is equal to 280. So both the functions are in terms of t. Then only you can find dx upon dt and dy upon dt with respect to the same variable. So x is equal to 80 square and y is equal to 280 is given. Differentiate with respect to t. Dx upon dt is equal to, here a is a constant, so t square derivative is 2t, so 280 is the derivative dx upon dt. Similarly, y is equal to 280 is given, dy upon dt is equal to 2a. Now we will apply the formula dy upon dx is equal to dy upon dt upon dx upon dt. dy upon dt is 2a and dx upon dt is 280. We have to substitute the proper values in the place of this one. So before substituting, you have to check the values. Is it correct or not? So 2a upon 280 is correct, and 2a cancel, 1 upon t is the final answer for this question. Okay, second question is find dy upon dx if x is equal to root of a square plus m square, y is equal to log of a square plus m square. Both the functions are in terms of m, so you have to take the derivative of x with respect to m and y with respect to m. So the formula will be dy upon dx is equal to dy upon dm whole divided by dx upon dm. So we'll first find x is equal to root of a square plus m square. So differentiating with respect to m, dx upon dm is equal to, this is in the format of root x, derivative root x is 1 upon 2 root x. Here 1 upon 2 into root of a square plus m square into derivative of a square plus m square. Since a square is a constant, derivative of a square is 0. Derivative of m square is 2m. So 2m upon 2 into root of a square plus m square, that's equal to 2 cancel, m upon root of a square plus m square. This is dx upon dm. Similarly, dy upon dm is equal to, this is in the format of log x format. So log x derivative 1 upon x. So here 1 upon a square plus m square into derivative a square plus m square is 2m. So 2m upon a square plus m square. Now dy upon dx is equal to dy upon dm upon dx upon dm, substituting both the values, and m cancel in the numerator. So 2 into root of a square plus m square upon a square plus m square. The denominator can be written as root of a square plus m square into root of a square plus m square. So one of the root of a square plus m square cancel from numerator and denominator. So the answer is 2 upon root of a square plus m square. Next question is find dy upon dx if x is equal to t plus 1 upon t whole raised to a, y is equal to a raised to t plus 1 upon t, where a greater than 0, a not equal to 1 and t not equal to 0. The x value is t plus 1 upon t whole raised to a. So this type of derivative also we already studied. Logarithmic differentiation is this. So take logarithm on both sides. We will get log x is equal to log of this term. So a into log of t plus 1 upon t. Differentiating with respect to t. Here the function is log x. So 1 upon x into dx upon dt you have to take. A is a constant, so a into log x derivative is 1 upon x. So in the place of x it is t plus 1 upon t, and you have to take the derivative of t plus 1 upon t, that is 1 minus derivative 1 upon t is minus 1 upon t square. So dx upon dt is equal to, cross multiplying this as ax upon t plus 1 upon t into 1 minus 1 upon t square. So dx upon dt is equal to ax into this function upon t plus 1 upon t. Similarly, y is equal to a raised to t plus 1 upon t is given. Taking log on both sides, log y is equal to t plus 1 upon t into log a. Derivative of log y is 1 upon y dy upon dt. That's equal to log is a constant. We have written here into derivative of t plus 1 upon t is 1 minus 1 upon t square. Now dy upon dt is cross multiplying this y log a into 1 minus 1 upon t square. Now from 1 and 2 dy upon dx can be written as dy upon dt upon dx upon dt. That's equal to y log a into 1 minus 1 upon t square, and in the place of dx upon dt we have substituted this. Then after cancellation 1 minus 1 upon t square and 1 minus 1 upon t square, after taking reciprocal it will be cancelled. So y log a into 1 sorry t plus 1 upon t, that will come in the numerator, upon ax. Now taking the LCM of this one, y log a into t square plus 1 upon axt. This is the final answer for this question. Next question is, find dy upon dx if x is equal to cos inverse of 4t cube minus 3t and y is given tan inverse root of 1 minus t square upon t. So this type of question is inverse trigonometric function. So we have to give substitution for this one. That type of question we already solved. So here put t is equal to cos theta. Cos theta, then therefore if you are giving t equal to cos theta, you must get the value after completing this one substitution. You must get some terms of uh, cos, then only it will cancel. For that we are giving substitution, because this is the formula of 4 cos cube theta minus 3 cos theta is cos 3 theta. You have to remember that formula. This is that formula. So you have to substitute that value. So after substitution you can give this value, because we know, or we all know, that 4 cos cube theta minus 3 cos theta is cos 3 theta. So cos inverse and cos cancel 3 theta, and in this type of differentiation you have to resubstitute before taking derivative. So theta is cos inverse t, that is 3 into cos inverse t. So x value is this one. Now taking derivative with respect to t, 3 cos inverse t, derivative of cos inverse t is minus 1 upon root of 1 minus t square. So 3 already is there, so minus 3 upon root of 1 minus t square, that is equation number 2. Then y is equal to tan inverse root of 1 minus t square upon t. The same substitution we have given here. After substituting, you are getting tan here. So that is why we are giving this substitution. So root of sin square theta upon sin cos theta. Sin theta upon cos theta is tan theta. Then tan inverse cancel. So equal to theta. In the place of theta, you can give cos inverse t. Derivative of cos inverse t is minus 1 upon root of 1 minus t square. Now we will find dy upon dx in terms of dy upon dx upon dt upon dx upon dt. So substituting these two values after cancellation, the root value denominators, root of 1 minus t square, both are in denominator, so you can cancel. So minus 1 upon minus 3, that is 1 upon 3 is the final answer for the question. Next question is, find dy upon dx if x is equal to cosec square theta, y is equal to cot cube theta at theta equal to pi by 6. So given x is equal to cosec square theta, derivative of this is in the format of x raised to n. X raised to n derivative is n into x raised to n minus 1. But here in the place of x it is not x. So you have to take the derivative of cosec theta also. Function of function. Composite function is given here. So 2 cosec theta into derivative of cosec theta is minus cosec theta into cot theta. So minus 2 cosec square theta into cot theta is equation number 1. Similarly, y is equal to cot cube theta is given. Differentiating, this is again x raised to n format. So 3 cot square theta into derivative of cot theta is minus cosec square theta. Adjusting, minus 3 cosec square theta into cot square theta. From equation number 1 and 2 we will get dy upon dx is equal to dy upon d theta upon dx upon d theta. After substituting these two values and after cancellation, cosec square theta cancel, cot theta, one of the cot theta cancel. Only one cot theta is remaining in the numerator. So 3 upon 2 cot theta is the answer for dy upon dx. But you have to find the value of dy upon dx at theta equal to pi upon 6. So at theta equal to pi upon 6, dy upon dx is equal to 3 upon 2 cot pi by 6. You have to substitute in the place of theta, it is pi by 6. Cot 30 is root 3. So after substituting, you are getting 3 root 3 upon 2 is the final answer for this question. Next question is find dy upon dx if x is equal to t plus 2 sine pi t, y equal to 3t minus cos pi t at t equal to 1 upon 2. So solution for this is x is equal to the given function differentiating with respect to t. Dx upon dt is equal to derivative t is 1 plus 2 into, this is sin x format, derivative sin x is cos x, but since it is not x, you have to take the derivative of this also. So 1 plus 2 into cos pi t and derivative pi t is pi. So 1 plus 2 pi cos pi t. Also y is equal to 3t minus cos pi t. Differentiate with respect to t. Dy upon dt is equal to 3 minus of the derivative of cos pi t is minus sin pi t and derivative of pi t is pi. So 3 plus pi sin pi t. From 1 and 2, after substituting in the formula, you will get 3 plus pi sin pi t upon 1 plus 2 pi cos pi t. Now you have to find at t equal to 1 upon 2, you have to find the derivative of this function. So you will substitute the value of t in the place of t here. So 3 plus pi sin pi into 1 upon 2 upon 1 plus 2 pi into cos pi into 1 upon 2. So sin pi by 2 is 1, cos pi by 2 is 0. So 3 plus pi into 1 upon 1 plus 2 pi into 0. That's it. 3 plus pi upon 1, that is equal to 3 plus pi is the final answer for this question. Some exercise questions are given to you. You have to solve it. Thank you.